Hi, good afternoon. How you doing? Well, here we are once again. आज हम लोग करेंगे DNF block and coordination compounds in one power pack session. So, are you ready? इन दोनों को साथ में इसलिए रखा है क्योंकि काफी यूनिक चीजें हैं दैट आर कॉमन, राइट? डी ब्लॉक एलिमेंट्स की ही चीजों को हम लोग, एफ ब्लॉक थोड़ा सा अलग है, अजीब है, बट डी ब्लॉक की आइडियाज को ही हम लोग यूज करते हैं कोऑर्डिनेशन में. सो द होल सेम थिंग, राइट? द ओनली डिफरेंस इज कोऑर्डिनेशन में क्रिस्टल फील्ड स्प्लिटिंग, हाइब्रिडाइजेशन, दोज थिंग्स, राइट? बाकी और ज्योमेट्रिकल आइसोमेरिज्म, बाकी सब तो काइंड ऑफ बोरोड ही है फ्रॉम डी ब्लॉक. सो व्हाट आर यू वेटिंग फॉर? शैल वी गेट स्टार्टेड? वेयर आर वी एट? मेरी आवाज साफ आ रही है? आर यू एबल टू हियर मी एंड see me clearly? Let me know first, and all that's good. Hey, Snigdha, Teethraj, Mayuk, and Pampa. Good evening to everybody. So where are we at? Oh, आज है 12 तारीख. 12 तारीख हो गया. 12 मार्च. मार्च भी खत्म हो रहा है. Okay, so this is where we are at, and हम लोग करेंगे परसों halogen and oxygen. This is basically haloalkanes, haloarenes, and alkoxyl ethers. I know that's a lot. उसके बाद carbon compound, which is acids, aldehydes, ketones, and lastly ये वाला हम लोग अमीन्स करेंगे. एंड एक्चुअली आई थिंक वी आल्सो हैव समथिंग मोर प्लान फॉर यू. प्रैक्टिकल ऑर्गेनिक केमिस्ट्री, प्रैक्टिकल जनरली केमिस्ट्री है, वो मैं I'll tell you when we can do that. I'll tell you when we can do that. खैर, let's get started. Now, Piyush on the JEE channel. Yeah, we are launching this thing called JEE की तैयारी, which is called JEET. That's what Piyush is talking about. It's on shop.byju's.com. That's where you can get it. Yeah, that was good time pass. I went to the office yesterday. Usually मैं घर से सेशन लेता हूँ, so I went to the office. And yeah, we were like, let's make some promos. And Lalit, the superstar from the maths team, who gets all of Bhumika's shorts to go viral, he helped us out with those. So we spent some time on that. It was good time pass. Yeah. Date देख के डर लगता है ना. It's okay. It's okay. It's fun. Like खत्म हो जाएगा, and then you'll be in college before you know it. You feel कि ये बहुत stressful है. Wait for college. How motivating is that? मैं आकाश से हूँ फैजल. Actually, I'm from BYJU'S, but yeah, Aakash BYJU'S, same difference, right? आजकल खैर, Aakash Digital. What is 104S03D3? What is that? I have no idea. What are you talking about, Signa? Oh, अच्छा, you're writing down the configurations. अच्छा, 1 4S. अच्छा, D. Okay. Question आपको दिख गया था, इसलिए आप लोग आंसर बता रहे हो. Okay. Let's do these first because ये सब D block है, ये सब F block है. So let's do all of these first, ठीक है? तो पहले इन सबका हम लोग एटॉमिक नंबर लिखते हैं, ठीक है? एटॉमिक नंबर क्यों लिखते हैं? क्योंकि दैट विल हेल्प अस फिगर आउट द एटॉमिक द इलेक्ट्रॉनिक कॉन्फ़िगरेशन. दिस इज अ जनरल कॉन्फ़िगरेशन. आर्गॉन का हो गया 18, एंड देन अगर इसका 2 ले लो तो 18 + 20 एंड व्हाटएवर यहाँ पे है. द ओनली एक्सेप्शन आर कॉपर एंड जिंक, जिसका जो है 4s1 होता है, एंड बाकी यू नो द ड्रिल. ओके, so let's figure out chromium 3+, copper 2+, Mn2+. पहले let's write all the ground states. Ground state देखो, इसका as I said exception है ये तो, right? Which is why it's not 4s2, it's 4s1. You know this, you've been mugging this for a long time. Yeah, what is this? Oh, this is chromium and copper, दोनों साथ में exception आ गए. Okay, great. Cobalt is 7, that makes sense. 5 5. Okay, now let's start removing electrons. 3 electrons इसमें से निकाले तो 1 और 2, मतलब बच गए 3. इसमें से 1 निकाला, बस ये निकल गया. इसमें से 2 निकाला, बस ये बच गया. इसमें से 2 निकाला, बस ये मिल गया. So this is the electronic configuration, right? This is going to be electronic configuration of these ions. Okay, hold on. यहाँ पे क्या हो गया? सेम ही चीज फिर से आएगी क्या? That's अजीब. खैर, small hiccup. This should not be there. Let me fix that. ये क्या हो गया भाई? I'm like ये. Whoops, technical glitches. Apologies. Let me fix that right over here. That's the good thing about doing things from home. मैं तुरंत fix कर सकता हूँ. When I'm in the office, इतना flexibility नहीं होती है in terms of, because I have more screens here than the office. Office there are 2 screens, here I have 3. So I can do these things on the fly, right? So let's fix it. Bob the Builder, can we fix it? Yes, we can. Okay, 3D3. Yeah, all right, perfect. ठीक है. All of you are giving me the right answer. Thank you for that. बिल्कुल बढ़िया, आप लोग बहुत सतर्क हैं. All right, volume. I'm going to talk in English. Tell me something you don't understand, and I'll repeat in English. All right. 3D3. Yeah, rest of them are straightforward, right? 3D10, 3D7, 3D5. Perfect. Teethraj, Mayuk, Snigdha, Pampa. RS volume has not answered, but all right. फैजल, ठीक है, कॉन्ग्रेचुलेशंस. आपको पढ़ाई करनी है, पढ़ाई करो. टाइम पास करना है, टाइम पास करो. यूज योर टाइम एज यू सी फिट. ठीक है? All right. Yeah, we build this thing, the solution. Khair, electronic configuration, Baki, let's do these 4 ions. And to be honest, I don't know the electronic configurations. I knew cerium and lutetium because these are extremes. Okay. But बाकी के मुझे देखने पड़े. I'm like, bro, how do you even get to these? खैर, yeah, F block is a thing, and sadly, you'll have to look at which ones where. I don't want you to mug the F block elements, but if you're aiming for that 650 plus core, then maybe mug F block elements and the electronic configuration. If you're not looking for a 650 plus core, ditch it, bro. Don't mug the F block elements के, एक कौन सा जो एलिमेंट कहाँ पे, it's not worth it. It's just not worth it. So anyway, इसके ground states अगर मैं लिखता हूँ, तो what's the main thing? It's similar to this. Xenon is going to be 54. Okay, so 54 से plus कितना हुआ? This is 7. This is 4. This is 14. Exactly, right? Is that right? No, that's wrong. 10 would be 64 and 7, 17. Okay, 17, yeah. And this is different. ये तो नहीं है. This looks like this is going to be 5F, not 4F, right? Because this doesn't fit in. Here, so yes, 17 becomes 14 and 3 because the general configuration of these is going to be, xenon के बाद 5D 0 to 1 and then 6 is usually 2, 1 to 2 जो भी है 0 to 2 कुछ भी हो सकता है, but right now mostly it's 6s2. ठीक है, so उस आइडिया को लेते हुए 7 में से 3 मैंने यहाँ निकाल दिए, 3 निकाल दिए, 3 निकाल दिए, उसके बचे कितने? 4, 1 और 14. That's how you go about figuring out F block elements. Now the 5F के लिए I figured this was xenon. 5F के लिए we'll have to look at radon. Radon is 86, so 4. Hence 3 again and 1. Okay. Now we finally got the ground state of the F block elements. हाँ सिंह, I understand. So F block configuration के बारे में यही चीज है. As I said, it is 5D 0 to 1 and 6S2. Or you can look it up in NCERT. You want to look it up in NCERT? आप खुद देख लेना NCERT में, right? Hey Vaishnavi, how you doing? How you doing? Good to see you here after some time. Thorium plus 4, radon. अच्छा, फर्स्ट प्रिंसिपल क्या है F ब्लॉक का? सिंह, फर्स्ट प्रिंसिपल यही है कि you have either xenon for 4F or radon for 5F. ठीक है, उसके बाद 6D, obviously there is also 5F which I'm conveniently forgotten, but 0 to 1 and 7S2. The main difference between 4F and 5F is 5F is a little more reactive than 4F because of worse shielding, but otherwise they are similar. We'll get to those things. Differences क्या हैं वो हम लोग आगे देखेंगे. खैर, 61, 58, 71, 90 और उसके बाद if you start removing electrons, you need to get 3 plus, 4 plus, 2 plus and 4 plus. Oh God, फिर से वही चीज आ रही है क्या? अच्छा हाँ, यहाँ पे है 3 plus. Okay, so we've got to remove 2 and 1. सब निकल गए. 4 plus 2, 3, 4. अरे, this is even better. 2 is this guy. Okay, 4 is सब निकल गए. Okay, so only this one has something, a 5D electron. Whereas, yeah, interesting. Yeah, 3D10 says Pampa. Okay, looks like आप लोग ने give up कर दिया है when it comes to F block elements. लगता है किसी ने F block elements नहीं पढ़ा है, which is okay. ठीक है, no tension. But again, I'm telling you, if you are looking for a score of 650 plus, you need to do F block. You cannot skip F block. And for all practical purposes, otherwise you can skip F block configurations for sure. ठीक है, this is how I'd go about calculating. So in a nutshell, what are we doing? हम लोग लिख रहे हैं पहले noble gas, ठीक है, for 3D and 4D, 3D and 4D. उसके बाद हम लोग लिख रहे हैं, okay, noble gas के बाद क्या है? You have let's just do 3D, 3D 1 to 10 and 4S 1 to 2, right? Similarly, for F block elements, you have a different noble gas, same idea, different noble gas. 4F 1 to 14, 5D 0 to 1 and 6S2. This is the usual configuration. ठीक है, आता है टाइपिंग में कॉन्फ़िगरेशन कौन लिखे? बिल्कुल सही बोला पीयूष, कौन लिखे कॉन्फ़िगरेशन? ठीक है, कूल. Why are manganese 2 plus compounds more stable than Fe2 plus towards oxidation to their plus 3 stage? So most जो प्रॉपर्टीज हैं डी ब्लॉक और एफ ब्लॉक की, दे हैव टू डू विद द इलेक्ट्रॉनिक कॉन्फ़िगरेशन. इसलिए मैंने पहला सवाल अजीब सा थियोरेटिकल सवाल लेके, आप लोग नीट की तैयारी करो, व्हाई आर डूइंग थियोरेटिकल सवाल? बिकॉज दैट सेट्स द फाउंडेशन फॉर एवरीथिंग दैट कोर्स इज गोना फॉलो. लिटरली सारी प्रॉपर्टीज आर बेस्ड ऑन these, you being able to write the electronic configuration, because once you can write it, then you can figure out magnetic properties, this, that, reactivity, सब कुछ figure out कर सकते हो उसके basis पे. D block easy, all right. So can you tell me then why are Mn2 plus compounds more stable than Fe2 plus towards oxidation to their plus 3 state? Like with everything else, इसका answer lies in the electronic configuration. सो मैंगनीज इज गोइंग टू बी 3d5 4s2 क्योंकि 25 है इसके इलेक्ट्रॉन्स और इसके पास होंगे 26 इलेक्ट्रॉन्स प्रोटॉन्स दोनों सेम होंगे अनचार्ज में। चार्ज स्टेट में हम लोग 3 इलेक्ट्रॉन्स निकालेंगे 2 और 1 और इसमें जो है सो दिस बिकम्स 3d4 राइट दिस बिकम्स 3d4 as well but here is the okay let's not remove 3 let's remove 2 actually remove 2 because we are comparing 2 versus 3 right so once you remove 2 this is what you get मैंने 2 निकाल दिए so this is 2 plus this is also Fe 2 plus okay not 3 plus Fe 2 plus and Mn 2 plus let's fix that also so that you guys don't get confused slide number 16 this should be 2 plus okay great fixed yeah cool so now if you are at the 3d state 3d5 state exchange energy वाला right exchange energy के कारण बहुत stable होता है 3d5 state half filled state so इससे 3d4 में जाना is going to be pretty difficult which is why manganese का oxidation from 2 plus to 3 plus is a lot whereas Fe 2 plus यार ठीक है already 4 में आ गया 3 में चले जाएंगे no problem this is the main idea 3d5 exactly 3d5 yeah absolutely Fe is 3d6 4s2 so should be 3d6 you're right you're absolutely right इतना ज्ञान दे रहा था कि ध्यान से लिखो और खुद ही मैंने ध्यान से नहीं लिखा बिल्कुल सही बोला आपने so this is not going to be 3d5 it's going to be 3d6 4s2 and after 2 इलेक्ट्रॉन चले जाएं it's going to be 3d5 so 3d6 yeah thank you for pointing that out Pampa I was wondering it seemed a little weird 2 electron chale gaye so it's 3d6 and in fact it'll be really stable so Fe really wants to go to 3 plus state because 3 plus is going to be d5 so yeah all right great we figured it out thank you and thanks to Pampa Mn 3d4 becomes plus 3 Fe becomes 3d3 stable in plus 3 Snigdha it'll be d5 no Fe 3 plus will be d5 I want to say because manganese is before iron manganese ka is 25 and Fe is 26 right so इसके अगर 2 इलेक्ट्रॉन निकालो so it has a 3d5 state इसके 2 इलेक्ट्रॉन निकालो it has a 3d6 state okay this is 2 plus now the 3 plus states are going to be d4 and 3d5 for again Fe and Mn that's why that's going to be lot pretty stable my bad no need for you to apologize मैंने गड़बड़ लिखा था describe the oxidizing action of potassium dichromate and write the ionic equations आ गया redox reactions electrochemistry और T block सब कुछ साथ में oxidizing action of potassium dichromate कैसे करोगे will you help me with this one yeah iodide iron solution iron 2 solution and H2S so the simple thing that I'll help you off as to get you started is this iodide मतलब I minus Fe2 becomes Fe3 plus like more salt S2 minus becomes this ठीक है ये हो गया ये तीनों है ऑक्सीडेशन अब रिडक्शन हाफ भी लिख लो रिडक्शन हाफ क्या है Cr2O72 माइनस बिकम Cr3 प्लस अब दोस्तों बैलेंस करो यही तो करना है डिस्क्राइब द एक्शन एंड राइट द आयोनिक इक्वेशंस करो भाई बैलेंस I'll start I'll give you a 1 minute head start and then I'll also go ahead with this 16:43 a good 13 minutes gone that's great we're good on time I think we can balance these pretty quickly आपने किया have you balanced these equations you should because ये NCERT में तो you should 2i minus gives i2 plus 2e thank you Mayuk wonderfully balancing the first one okay so what I'll do is I'm going to write all of them together ठीक है just for in the interest of time and then into 3 okay why into 3 Mayuk can we balance the other side also so I minus में है 1 इलेक्ट्रॉन अगर मैं आधा I लूं तो इसमें है 1 इलेक्ट्रॉन इसमें है 2 इलेक्ट्रॉन और यहाँ पे क्या है अगर मैं इसको आधा लूं then I have a charge of -1 वो तो ठीक है बट एक क्रोमियम एटम और यहाँ पे मैं +3 इलेक्ट्रॉन डालूं तो ये हो जाएगा डोंट वरी विल गेट रिड ऑफ द आधा बाद में डोंट वरी अबाउट दैट सो आधे के लिए इफ आई टेक हाफ ऑफ दिस आई गेट 1 इलेक्ट्रॉन 1 2 and 3 ओके कूल सो लेट्स बैलेंस दिस फर्दर कैसे H+ डाल के पहले हम लोग H+ डालेंगे क्रोमियम की तरफ क्योंकि यहाँ पे है चार्ज ऑफ टोटल -1 प्लस -3 इक्वल टू -4 यहाँ पे है +3 तो यू विल ऐड 7H+ ऑन दिस साइड आप लोग भी करते रहो मैं तो बता ही रहा हूँ तो 7H+ इधर डाल दिया ठीक है बाकी सब चीजें कुछ नहीं बदली अब लेट्स गेट रिड ऑफ दैट हाफ मल्टीप्लाई दिस होल थिंग बाय 2 मल्टीप्लाई दिस विद 2 इसको ऐसे ही रहने दो इसको ऐसे ही रहने दो ओके But if you do that, then what do you do? ठीक है. Now इसमें है कितने इलेक्ट्रॉन? अगर मैं 2 से किया 6 इलेक्ट्रॉन हो गए. इसके 6 हुए तो get this to 6 इलेक्ट्रॉन. I have to do into 3 more into 6 into 6. बस that's it. हो गया बैलेंस खत्म. देखो within 30 seconds we balanced all the reactions. ठीक है. I know it is not completely balanced because you have to add some more H plus here and there. थोड़ा बहुत पानी और करना है, but ठीक है कर लेना. This way of doing this, putting half fractions is a lot easier because once you use a fraction, then you will easily figure out कि अच्छा एक एटम में कितना इलेक्ट्रॉन चाहिए. That's why using fractions. Maybe you have not seen other people use fractions before. भाई fraction कौन use करता है, क्यों करते हो? Easier to multiply. The reason why I use fractions is कभी-कभी students forget कि if you have Cr2 giving 2 Cr, it is 6 electrons, not 3 electrons, right? That is harder to remember. It's easier to do this half thing मेरे हिसाब से. ठीक है? 3 electron RHS में says Snigdha. In which one? Which one? इसमें तो LHS में होंगे ना, because this is getting reduced and this is getting oxidized, है ना? तो टोटली 6 इलेक्ट्रॉन जाएंगे. इसमें लगता है 6 नहीं होगा, इसमें 3 होगा. सॉरी, इसमें 3 होगा, not into 6. This last one is going to be into 3. Yes, Mayuk, thank you for that. So Srithra is saying 2 Cr2O7 2 minus 14H plus and 6. Exactly वही मैंने जो लिखा है उसी को 2 में डालो. तो पानी भी डालना पड़ेगा. तीसरा दूसरी तरफ RHS में 2 Cr3 plus और 7 H2O. बस हो गया. बाकी तुम लोग ऐड कर लेना. ठीक है. Add both of these half reactions together to get the full thing, and you are good. You are good to go. We'll just have to check what to do about this negative charge and this negative charge. वो आप बैलेंस करके figure out कर लेना. Okay, cool. This is how you would start doing it, and this is a quick way of balancing it. और हमने थोड़ा बहुत redox भी इसी में साथ में revise कर लिया. Let's go to the next question. ठीक है? All right. Predict which of these will be colored in an aqueous solution. Ti3 plus. I feel it's not. Oh, it is titanium. Titanium 3 plus, vanadium 3 plus, copper plus. ये तो नहीं होगा colored. Sc3 plus and cobalt 2 plus. Give reasons. ये हो गया D7 configuration. Sc scandium ये भी नहीं होगा colored क्योंकि 4s1 सॉरी 4s2 3d1 होगा इसका. आई एम जस्ट क्विकली जो भी मेरे दिमाग में आ रहा है मैं लिख रहा हूँ. Scandium, vanadium is 3d2 4s1 sorry 4s2, so 3d1. This is going to be colored. Ti3 plus also 3d4 4s1 going to be colored. Why am I writing 4s1 4s2? थोड़ा घोष हो गया. All right, let's do it properly. This is a 30-second way of doing this. Okay, if you want to do it properly, ground state पहले लिखो as usual. Titanium is argon plus 3d2 4s2. Titanium is 3d2 or 4s. Is it 3d4? I think it's 3d4. Brilliant. Scandium, vanadium, no, what is it? Scandium के बाद क्या आता है? देखना पड़ेगा. See, I always forget the first three. ptable.com. Let's open up ptable.com. I am not kidding. मैं बिल्कुल ड्रामा नहीं कर रहा हूँ. I honest to God do not remember Scandium के बाद क्या आता है. Not kidding. Scandium के बाद आता है Titanium. ओ तो 3d2 होगा ये. हाँ तो सही लिखा है मैंने. Trust my background work. This is right. It is not 3d4. अच्छा 4 तो chromium हो गया ना. All right. Vanadium भी सही है. ठीक है. Cool. Yeah, I keep forgetting this. ठीक है. When in doubt, open the periodic table. Yeah. By the way, the pinned comment, if you're wondering what that is, that has a list of all the sessions that generally work on. You can check it out if anyone is watching this randomly, not live. Okay. So, okay, we are good. These are ground states. Now let's remove 3 electrons, 2 and 1. 3 electrons, 2 and 1. Copper plus, yes, को हटा दो. Sc3 plus, सब हट गया. CO2 plus, ये हट गया. So, out of these, ये दोनों नहीं होंगे colored. I'm sorry, ये दोनों, yeah, these both are not going to be colored. And everything else should be colored. Everything else should be colored. So Ti3 plus, Vi3 plus, and copper, cobalt 2 plus should be colored, right? That's the idea that I'm going with right now. Cool. And do you guys agree with this? Anybody disagrees with this? 125 DD transition. 125 DD transition. All right. 1, 2 and cobalt 2 plus. Perfect. All right. Ti3 plus violet, cobalt 3 plus blue. Piyush is on fire. Baap re. Incomplete D. Hence, that's why DD transition. Okay. You've learned the whole period. Snigdha, bro. Hats off to you. You've learned the whole periodic table. Okay, that's great. That's lovely. You have a lot of Grit. बढ़िया. Compare the chemistry of actinoids with that of lanthanoids with reference to electronic configuration, oxidation states and chemical reactivity. हम लोग बात कर रहे थे ना कि F block elements को कैसे analyze करें. Let's see. The general way of doing this, and I kept writing 1, but कभी-कभी 0 भी हो जाता है. Let's see. I'm gonna explain this to you. Take this as a little bit of a theory thing. 4F 0 to 14 is the foundation, as Singha was asking, right? 5D 0 to 1, 6S2. This is 5F 1 to 14, and this again just what is from NCERT. ठीक है, मैं NCERT की चीजें बता रहा हूँ आपको. And this takes part in bonding a lot more than the lanthanides do because was shielding, right? The very diffuse electrons, so they take part in bonding easily. Okay. Usually +3 state is the most common oxidation state, but at times you have +2 and +4 when you have the F7, F14 and also F0 configurations. Okay, in configuration maybe +2 or +4 ho sakta hai. Mostly it's +3 state that's popular, yeah, and that's because 5F, 6D and 7S they have similar energy levels. मतलब कि इलेक्ट्रॉन्स यहां से वहां बहुत आसानी से जंप कर सकते हैं. Actinides show more oxidation state, more reactivity. Yes, Piyush. Lanthanides have 6s2, 5d 0 to 1, 4f 1 to 14. Lanthanides have 0 to 1 to 14 is what 0 to 14 is what I've seen. But is it 1 to 14, Mayuk? Let me just check. Since Mayuk is saying that, let me again check this. Okay, let's go ahead and open D block elements. Oh, yeah. On NCERT. We will check. Lanthanoids. Contraction की बात हो रही है. Lanthanoids. Where is the oxidation state? Yeah, I just saw Dune. I'm in that mood. Hold on. Where is the electronic configuration? I'm looking at NCERT if you're wondering why I'm staring at my screen. Common oxidation states. Yeah, electronic configuration. Finally, oh, that's actinoids. So lanthanoids कहीं ना कहीं होना चाहिए. Okay, never mind. All right. 0 or typing error. Okay, cool, great. Okay, let's move on then. ठीक है. The interesting thing is that the earlier members are more reactive and they're similar to calcium. And इस चीज पे भी नीट पे सवाल आ चुका है, जेई में भी आ चुका है. The later ones are as reactive as aluminium, which means they're less reactive. Okay, later elements. Later matlab left to right. Left wale more like calcium, right wale more like aluminium. Okay. Another small bit of information. They do not react with alkalis because they have a basic behavior. They do react with HNO3, and yeah, cool. They form oxides plus hydride when you react with HNO3. Small bits again from NCERT. Let's move on to the next question, which goes on to coordination compounds. 4F and 5D, not much buried and almost comparable energy, less oxidation states. Okay, yes, Piyush. Less oxidation states, primarily +3. Yeah, Piyush. फॉर्मूला बताओ पांचों एलिमेंट्स का, पांचों कंपाउंड्स का. टेट्रा हाइड्रोक्सिडो जिंकेट. आई एम गोना हेल्प यू आउट बाय पुटिंग बार्स. टेट्रा मतलब 4, हाइड्रोक्सिडो मतलब OH, पोटेशियम जिंकेट मतलब Zn. अब बताओ फॉर्मूला बता दो. पोटेशियम, ओके, K. Oh, this is an anion, right? Because potassium doesn't form these things. Tetra is 4, chlorido is Cl, palladate. What is palladate? Palladium. Palladium 2. Okay. Palladate, when there's ATE, this is an anion. This is a cation. Please in the chat let me know what you think these formulae are going to be. And don't get lazy. Type it out. It's okay. It's just the bracket. Fine. Di2amine, NH3. Di2 chlorido, platinum, PT2. This is a cation. Okay. Nickelate, anion. Potassium tetra 4 cyanido Cn. Okay. Pentamine nitrito O. ये nitrito O क्या बला है? Cobalt 3. This is a cation. What is this nitrito O? Nitrito O, nitrito N. ये सब क्या होता है? This is talking about the element that bonds with the metal. So the difference is that in NO2 and in nitro or this group basically, you have these forms. This is nitrito N and this is nitrito O. Okay? Okay, now I see some options people typing in. Great. ZnOH4 2 minus. Absolutely. Bilkul sahi Snigdha. Mayuk. Vaishnavi 2 minus. Piyush also 2 minus. Can't be 2 plus. Minus 2 power. Yeah, cool. got it. Tisraj, absolutely. ONO, NO2, ONO, ambidentate ligand. Okay. All right. Sure. Yes, it is. NO2 joined by O. K2 PDCl4. Okay. Second one. Lovely. तीसरा सेकंड दूसरा बताते हो K2 PDCl4 परफेक्ट तीसरा वाला क्या होगा कीप द चैट गोइंग बाकी लोग जिसको जो आसान लगता है वो डाल दो इट्स ओके एट दिस पॉइंट इन टाइम K2 PDCl4 या बिल्कुल सही आई विल डू द नेक्स्ट वन डायमीन क्लोरिडो मतलब कि दो NH2 दो क्लोरो लाइक CCl ग्रुप्स एंड प्लैटिनम नाउ द थिंग इज कि प्लैटिनम is a 2 plus charge. Chlorine दो है -1 वाले. So it's going to be a neutral. This is a compound itself. This is not a cation anymore. I know I wrote it's a cation, but this is a compound in itself, right? This is not an ion. I know. मैंने starting में लिख दिया था ion, but it's not an ion. That's interesting about this one. Yeah, PPNH3 whole twice Cl2. बिल्कुल सही. Last two, potassium tetracyanidoniculate is this is definitely an ion. An ion. This is cool. So you've got K2, NiCN4, 2 minus. What have you mugged about this? Does it stand out? NiCO4 versus NiCN4 versus NiCl4, 2 minus. ये सब चीजें आपने पढ़ी है ना? खैर, one is tetrahedral, one is not. One forces pairing, one does not, etc., etc., etc. You know the drill. Pentaamine nitrito O. Pentaamine, this is 5 amines. Nitrito O is this guy, cobalt 3 plus. Now nitrito O does not have any charge. That is nitrosyl, okay? NO plus is nitrosyl. Don't get confused between the two. Okay? It's going to be K2 NiCN4 Snigdha. Yeah, absolutely right, Teethraj. Bilkul sahi. Because cyanide has a -1 charge. Nickel has a +2 charge. That's what is given over here. Nickel kahan gaya? Nickelate. But nickel has a +2 charge. Hence, it will be K2 NiCN4. Okay? No doubts, right? Shall we move on? ONO +3. Okay, perfect. Mayuk. Let's go. Let's move on to the next one. आगे बढ़ते हैं. How many geometrical isomers are possible in these coordination entities? Interesting. Chromium C2O4 3 minus or cobalt NH3 whole thrice Cl3. Okay. How do you coordination? How confident are you in this whole geometrical isomerism business? Are you confident at all, or is this like, woof, ye kya ho raha hai yahan pe? What do you think? What is your opinion on this? And I have another question, right? What happens to when you have any bidentate ligand? Like say here I have oxalate. What if I instead of this I put En? Any bidentate. Do you think it will matter which species I put in there, which ligand I put in there? Does that matter? Does that affect geometrical isomerism at all? Yeah. And this is optically active. दो अलग-अलग सवाल पूछ रहा हूं मैं. I'm asking, does it show geometrical isomerism? Is it optically active? Two different questions. सोच के बताना. Chromium draw करते हैं. ठीक है. This is En or in this case OX, not En. OX. Okay. OX and OX. So this is your plane, so to speak. Is this optically active? What do you think? क्या लगता है आपको? 0 and 2 chelating ring you will clear by revising. Okay, all right. So different spatial amine, no GI, लेकिन optical is zero. Okay, thanks Piyush. Yeah, there's no plane of symmetry. Center तो है ही नहीं, center of symmetry है नहीं, but plane of symmetry भी नहीं है. right? So it's going to be active, optically active, but it does not show geometrical isomerism. What is geometrical isomerism, right? Geometrical isomerism का मतलब है cis और trans वाला business, but it gets a little bit complicated. Like if you draw a compound like this, if I draw a compound like this, can I talk about cis trans here? How do I talk about geometrical isomerism in a compound like this? I can do this whole permutation combination and see कि चलो इसका हम लोग जो है एक और बना देते हैं. Okay, we make another one like this, but it's got a different way of talking about it. You call it FAC and MER, meridian, and what's FAC stand for? I know MER is meridian. What is FAC? Is this what is FAC? It's not meridian. Okay, meridian. No, meridian. Yeah, my Angrezi kharab hai. Okay, facial. Okay, that one was easier. FAC was easier. What is the meaning of this FAC and MER? कोई बता सकता है इसको क्यों बोलते हैं FAC और MER? एक बार तुम लोग समझ जाओगे, you'll never forget it. ठीक है? This is different from cis and trans. Cis और trans तभी बात कर सकते हो if you have say A4 B2, then you can talk about cis and trans. But if you have this sort of a thing, whereas A3 B3, it's hard to do the cis trans business, right? Because you don't have fixed number of things. You have a different number. Okay. But what does that mean? Thanks Tanushree and Snigdha and Piyush. Thanks for your inputs. इसका मतलब क्या होता है? Face मतलब चेहरा. किस चीज का चेहरा? What is this? What is this structure? You got one center, and then you've got 4 vertices here. ठीक है? And you've got 2 more vertices here. ठीक है? So what this structure forms, and I'm going to erase these other backward wali cheezein that are not important. This is an octahedral. Octahedron. आपको याद है ये? This idea of what is an octahedron is, if you had solid state in your syllabus, we would have spoken about this more, but since you don't have it in your syllabus, octahedron मतलब 8-sided figure. 8-sided figure कैसे? यहाँ देखो ऊपर 4 faces, नीचे 4 faces, है ना? This is how it becomes an octahedron. Octahedron में तो 8-sided ना, square हो गया 2D में, 3D में cube हो गया ना, वैसे ही this is an octahedron. एक pyramid ऊपर, एक pyramid नीचे चिपका दो, ठीक है? Okay. Now, if these ligands form the face of the octahedron, you call it this FAC isomer. ठीक है? And they do. Look, you can see कि ये face बना रहे हैं. समझ में आया? Pretty cool, right? Exactly, Piyush. Perfect. Yeah, I'll talk about that. Sahasra Yug. That's nice. Sahasra means 1,000, doesn't it? Sahasra. I'll talk about what is meridional. I'll talk about that. Meridian. Meridian का मतलब क्या होता है? Meridian से we'll get meridional. Okay. Did you guys understand FAC or facial? Do you understand that? Yeah. Okay. So it's the face of the octahedron that we're talking about. Okay. Now what is this meridian? Meridian मतलब something that passes through stuff, right? Le Meridian, the hotel, and the meridian of whatever, this or that. So geographical stuff, right? Anyway, my geography is not that good. Now, if I draw that same amazing octahedron फिर से, you can see that these guys are now literally cutting across the octahedron. Not on the faces, cutting across, forming different planes through the octahedron. So, these planes bisect the octahedron. I know, मेरे सर के पीछे आ गया. You understand this, follow this, right? Hence, it's called MER. Okay, cool. थोड़ा सा रिवाइज हो गया, but some students इन सब चीजों से डरते हैं, so इसलिए मैंने सोचा कि इसके थोड़ी सी थ्योरी की बात कर लेते हैं. Normally, in our sessions like this, we don't talk so much theory. We do questions. जरूरी है. अगर इस पे सवाल आया, students get scared. I hope now you will not get scared and you will be able to do this easily. ठीक है? So none and 2. Okay. Let's draw all isomers, geometrical and optical, of these 3 compounds now. ठीक है? Okay, I'll help you with this one. Remember, I told you A4B2 में cis trans होता है, right? This is just like A4B2, right? En2 is A4. So I will draw it like this, but there's a small difference. If I were to draw it like this, there's nothing. If I draw a mirror, it's going to be superimposable. You see that? अगर superimposable है, and now this is, and it also has a plane of symmetry, like a lot of planes. This is not okay. What about the other one? If I draw this structure, this was trans, obviously this is cis. In the cis structure, I have non-superimposable mirror images. So here you go, GIs, and optically active as well, both of these. Okay, cool. The next one, I have CO, NH3, Cl, and then En2. Now this one's very fascinating. Why is it fascinating? Because again, इसमें से हम यहाँ पे Cl हटा के NH3 यहाँ पे डाल दिया है. But again, there is a plane of symmetry. Okay, let's mix things up. Let's go to the cis isomer. This again is going to be optically active, and GI non-superimposable 1 2 GI होगा and 1 का optically active होगा. पीयूष 1 optically active होगा क्या? Cis structure has no superimposable. Yeah, exactly, non-superimposable, बिल्कुल सही. Optically active ये कैसे होगा? Is this this one? Yeah, this one is going to be yes. बिल्कुल सही. Last one is this chap right here. This one is fascinating. इसमें हर चीज, whatever you do, is going to be completely different, right? Look at this. Why is it going to be completely different? Because now there is no plane of symmetry इसमें itself. I can't find one. Whatever I do, I don't really have any plane of symmetry. So now I'm going to get a lot of isomers. How many specifically? Okay, I have swapped these two to get one more like this. This I've kept these guys in the equatorial position. Okay, this is the equatorial position. मैंने En को यहाँ पे रखा है, and then I move these two around. I'm keeping these fixed. ठीक है, so I've got two this way. Then I move En between planes, between axial and equatorial. मैंने यहाँ पे डाला है. Then again I swap out NH3 and Cl की positions. ठीक है, here I put Cl, here I put NH3, NH3. This one's a little confusing, and I think this is like the maximum amount of complicated is going to get. इससे ज़्यादा complicated नहीं चीजें जाने वाली है for NEET, and this is how you get 4 in this one. I know ये थोड़ा complicated है, but since it's in NCERT, it's there. I don't know why it's in NCERT. I don't know why they want doctors and engineers to know all of this. I don't understand that. I haven't understood that for 20 years, but sadly ये है, which is why I'm here teaching you this. I know थोड़ा ज़्यादा हो गया ये. Are you guys all right? This is how you go about doing it. Again, 650 plus, bro. Otherwise, bitch. ठीक है? I'm being very frank with you. If you know how this works, बहुत अच्छी बात है. अगर नहीं समझ में आ रहा है, and you're aiming for a score of greater than 650, then please study. Otherwise, ठीक है, छोड़ दो. It's okay. आएगा तो छोड़ देना. But ये NEET में काफी सालों से I have not seen this kind of a question. But since NCERT में है, so I'm mentioning it. All right, Piyush. Good to know कि आपको आसान लगता है. That's lovely. Now on to quote unquote easier things. This one is paramagnetic, and this is diamagnetic. क्यों? क्यों 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 ये दोनों है strong, but how come one is paramagnetic while the other is diamagnetic? The answer as always lies in पहले electronic configuration figure out करना पड़ेगा. Electronic configuration. Okay, this is going to be 3D4, 4s2. ये क्या होगा? This is going to be 3D8, 4s2, and this is 2 plus, this is 3 plus. ये दोनों चले गए, ये बन जाएगा 4 3D4 से this becomes 3D3. Okay, that is 3 plus. और इसका 2 plus मतलब 3D8. Okay, so now here's the interesting thing. Although there is a strong field ligand, pairing happens. Pairing का मतलब क्या होता है? When does pairing happen? When does pairing not happen? Pairing happens if and only if pairing energy is lower than these splitting energies. And in this case, ये है ऑक्टाहेड्रल कॉम्प्लेक्स, ये है टेट्राहेड्रल कॉम्प्लेक्स, इसलिए मैंने दोनों चीज लिखा है। ऑक्टाहेड्रल कॉम्प्लेक्स के लिए दिस इज द स्प्लिटिंग, ओके। टेट्राहेड्रल कॉम्प्लेक्स के लिए दिस इज द स्प्लिटिंग, ठीक है। ओके, व्हाई एम आई ड्राइंग दिस? बिकॉज पेयरिंग का कॉन्सेप्ट ही नहीं आ रहा है भाई, इज जस्ट गोइंग टू चिल। तीन यहाँ पे बैठेंगे और यहाँ पे 1 2 3 4 5 6 7 8 आई, ये क्या हो गया? What is that? What happened here? How do you explain this, guys? If this is actually happening, यहाँ पे pairing हो रही है, oh, ये वाला भी भाई साहब pair कर जाएंगे maybe. But if this pairing happens, what is happening here? NiCN4 में क्या करें? T2G orbital degenerate, no pairing for D3. D3 is fine. Can you help me with NiCN4? Oh, T2G6. I don't think this T2G is just T2. Mayuk is just छोटा सा क्या बोलते हैं? Is just called this, okay? There's no G. There's no G, okay? T2 orbital generate, no pairing for D3. T2G, okay, this fine. T2G इधर, E इधर. But cyanide में क्या हो गया? कुछ गड़बड़ लिखा गया? NiCN4? Okay, hold on. 3D8. How do we figure out 3D8 in NiCN4? 2 में VBT DsP2. All right, this works. Yeah, Piyush, this works. So pairing happens here and here. Okay, hence you get DsP2 and not D2sP3 or anything, any weird shit like that. So here's the main idea. Okay, formally लिख रहे हैं, वो तो मैंने scratch करके थोड़ा बहुत लिखा था. This is DsP2, this is D2sP3. Why is this D2sP3? If we go back here, D2, let me write a different color यहाँ पे, ठीक है, ताकि you're able to point out and see clearly. D2 and then sp3. This is going to be DsP2. ठीक है, cool. Pairing against Holmes rule. Okay, yeah, all right, cool, perfect, perfect, perfect. Theory है, yeah, it's direct theory, but you need to go through it a little bit. So we went through it थोड़ा सा quickly. A solution of NiH2O6 2 plus is green, but a solution of NiCN4 2 minus is same चीज है, सेम ही चीज फिर से पूछ रहे हैं हम लोग, ठीक है। यहाँ पानी है and this is octahedral, this is tetrahedral. Colorless क्यों है? क्योंकि it has no unpaired electrons, strong field ligand है, and यहाँ weak field ligand है, right? So the splitting wise, and I'm not spending much time on this because we did that. पहले हमने already इसको ध्यान से देखा. Weak field ligand है, weak field ligand होने के बाद भी यहाँ पे होती है pairing, and यहाँ पे pairing नहीं होती है, ठीक है? So this sp3d2 and this dsp2, and this is going to be colored. Okay, let's move on. No unpaired electron, low spin complex. Okay, all right, perfect, perfect. Thanks, Piyush. Yeah, easy one. All right, lovely, 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 lovely. Amongst the following ions, which one has the highest magnetic moment value? Okay, first is octahedral. Yes, absolutely right. Second wala tetrahedral tha. How do I know octahedral, tetrahedral? Because of the number of ligands here. If there are 6 ligands, it's going to be octahedral. If there are 4 ligands, it's going to be either tetrahedral or square planar. In this case, square planar. I know we use tetrahedral splitting energy, but if it's dsp2, it's going to be square planar, right? Okay, anyway. Among the following ions, which one has the highest magnetic moment value? Same difference, same difference. Ligand सब में same है, तो फर्क क्या होने वाला है? This is going to have no electrons at all. 2 plus यानी कि 3d6, 3 plus यानी कि chromium 3d4, right? So 3d4 versus 3d6 is what you've got to compare. What do you think? इसका आंसर क्या होगा? B? All right, you're quick, bro. You're quick. 3d3, huh? Not 4. Where did I mess up there? 3d4, 4s2. 3d4. Oh, nahin. See, I always write this wrong. I know it's supposed to be basic, but khair, 4s2 and 1. फिर भी 3d4 होना चाहिए, not 3d3, right? 3d4. Slide number 74. Let's fix that. This should be 3d4, right? Oh, no, 3d3 is good. 3d3 सही था, 3d3 सही था. 3d3 सही था, because it's 3d5, 4s1. 4s1 से एक गया, दो गया. 3d3 is correct. Yeah. Why we're second guessing? Yeah, 3d3 is good. All right, perfect. Cool. 6 versus 3. And so you have 4 electrons here and 3 electrons here. No pairing because they're all weak field ligands. Perfect. B is the higher one. Okay, इन सब में से सबसे स्टेबल कॉम्प्लेक्स कौन सा है? सबसे स्टेबल कॉम्प्लेक्स कौन सा है इन सब में से? जल्दी से बताओ. We covered a lot of questions today, but it's only because you were all quick. Yes, Pampa, Vaishnavi, thank you. Titraj, Mayuk, and Snigdha, Piyush. Wonderful. Yeah, Snigdha. First one had 3, second one had 4. बिल्कुल सही. Stability कैसे देखोगे कॉम्प्लेक्स की? Stability of complex. How do we identify stability? क्या करें इधर? लिगैंड देखें क्या? लिगैंड है इधर स्ट्रॉन्ग, इधर वीक, वीक. हाँ, ये दोनों है स्ट्रॉन्ग. अब क्या करें? 3 is most stable due to bidentate ligand. Captain Lucky Bharadwaj ji also says C. Mayuk also says due to chelating rings. C is correct. Tanushree and Snigdha are all saying C. You guys got this one. No drama gets past you. Chelation is the right answer, and hence this should be it. Okay, lovely. आखिरी सवाल आज का. Ligand में chelate, whatever you call it. What will be the correct order for the wavelengths of absorption in the visible region for the following? Visible region इन सबके ऑर्डर क्या होगा? वेवलेंथ का ऑर्डर क्या होगा? बिल्कुल सही तीर्थराज, पप्पा, लवली. हाउ डू यू फिगर आउट द ऑर्डर ऑफ वेवलेंथ? इसमें थोड़ा सोच के बताइए. How do we do this wavelength of absorption? So, look, everything absorbs some light, and what you see is the light that does not get absorbed, the complementary color, right? Why am I saying this? Well, KMNO4 is purple because it absorbs yellow light. Yellow का complementary color है purple. So absorb करता है yellow light, and you see what it does not absorb. So light is coming in from everywhere. Like white light मतलब सारे wavelengths are coming in to KMNO4. वो yellow absorb करके purple दिखाता है. Why am I saying all this? Because color of absorption and the color you see अलग-अलग है, बिल्कुल अलग है. ठीक है? Okay. Wavelength inversely to energy 3 to 1. 3 to 1. 3 to 1 says Citraj and Piyush both. Okay, like nice. What is the strength of ligands over here? Strength of ligands here looks like this is the strongest, then maybe nitro, and then water. Yeah. Oh, sorry, my bad. This has the highest. Yeah. NO2 minus है. NO2 minus? Yeah. Oh, it is NO2 minus. How do I know it's NO2 minus? Because of this 4 minus charge. Yeah, Ni2 plus 4 minus charge, matlab all of these 6 have a negative 1 charge. Okay. So NO2 minus is more than NH3, more than water. Okay, great. Wavelength क्या होता है? Hc by lambda. So if energy is high, wavelength must be low because they're inversely proportional. That's it. Nothing fancy here. Okay. So order of wavelength सबसे ज्यादा और wavelength उसकी होगी जिसकी सबसे कम एनर्जी है. जिसकी सबसे ज्यादा होगी 1, 2 and 3. That will be the order of wavelengths. So as our friends pointed out, 3 is greater than 2 is greater than 1. Yeah, bilkul sahi Vaishnavi. Absolutely right. Wow, that was very quick. We solved a lot of questions together. So what's on your mind? Is this helping you guys? You know, I know you've been studying for 2 years, but just some feedback on this quote unquote series. This is helping you out. And what would you want me to do after this? Since we have finished this a little bit early and we're almost at the end of whatever we've planned, right? हम लोग ये सब करेंगे. इसके बाद आप क्या चाहते हैं? आपके लिए क्या करें? Any inputs on what we should do? That's it. We are done with today's session. Wow, जल्दी हो गया. Happy, yeah, sure. So, do you have any suggestion? What would you like us to do afterwards? Maybe April 4th to 15th, we'll be a little bit busy with the whole JE thing. But उसके अलावा, besides that, what would you want us to do for the last 15 तारीख से 5 मई तक जो लास्ट के 20 दिन है? What would help you? Let me know. If you have any inputs, you can find me on this. I teach Chem on Telegram or on Discord, or you can also leave comments on this video itself if you have any inputs on what you'd like from this channel for you for this. If you are giving the NEET exam right now in 2024, अगर आप 25 में दे रहे हो, 26 में दे रहे हो, 27 में दे रहे हो, that's far off. But sure, either way, what do you want? If you are giving your JEE exam in 25, say, per se, or 26 per se, you're like, start whole concept already. My boards are getting over. There are some students who ping me. Today is the 12th, right? 13th is when their board exams get over. There's a student called Harsh for them who like, let's go with 11th grade stuff. Sure, that input is welcome as well. Then there are some students who have finished the 11th and who have finished 11th now. They're like, yaar, 12वीं का शुरू करो. So what would you want me to do in 12th? Would you want me to do solutions, kinetics and all that? Do you want me to do organic chemistry first? Inorganic? क्या चाहते हैं 12th में? 11th तो I'm going to start with mole concept. ठीक है, उधर मैं अपना ज़्यादा choice ही दूंगा. 11th I'll start with that. But 12th, you tell me whatever you guys want. Practical chemistry, purification वाला part, okay, all right. Short revision or one shot? वैष्णवी, कितना short करेंगे revision? हम लोग एक सेशन कर तो रहे हैं और बहुत shortly हम लोग short revision कर रहे हैं. I don't understand one shots. I think one shots are useless here. You get the feeling of कुछ हो रहा है, but आप लोग खुद NCERT पढ़ो. That will help. I am ready to take full-fledged classes. Yeah, but I think that will be most relevant to 11th standard students and students going from 11th to 12th and 10th to 11th. बाकी जो जिनका NEET अभी जल्दी है, we can do some PYQs from JEE Main if that helps. I'm not kidding, because आजकल JEE Main और NEET का it's very similar. The only difference is JEE Main has 5 questions that have numerical entry. Otherwise, the type of questions is exactly the same. The level of questions is exactly the same JEE Main के NEET के. तो मेरा suggestion एक तो ये है, we can do that. ये कर सकते हैं हम लोग NEET channel पे. What do you think? Just after that, हम लोग JEE Main के कुछ सवाल का practice आपको करा सकते हैं. Physics or chemistry at least, if you like that. Or if you want something else, बताइए. We will try and do something. Yeah. Sultana, okay. All right. Form भी भरा नहीं. Okay. All the best for that, Sultana. All the best. अजीब चीजें होती रहती है लाइफ में. Anyway, thank you everybody for your time. It's been fun teaching you as always. I'll see you again. कब हम लोग मिलेंगे? परसों. Halogens and oxygen compound. That's going to be haloalkenes, haloarenes, and carboxylic acids, ketones, and aldehydes. सब चीज साथ में. If you want to check higher order thinking questions, then come check out यही same चीज carbonyl compounds वाला जो हम लोग बाद में 15 तारीख को करने वाले हैं on 14th. Oh, by the way, this Friday I have a class for you at 6:30. Yeah, that's the only extra thing. Usually it's Tuesdays, Thursdays, and Saturday. Here I also have a class on Friday at 6:30 p.m. with you. So please come check it out there. ठीक है? Question paper चाहिए पापा. Look at that. Good. Aadhaar update. All right, Sultana. All the best with that. ठीक है? Thank you so much for your time. Bye. Okay, you like the JEE Main idea? All right. क्या करूं? Sultana, I guess mail them. Why don't you send them a mail? NEET को mail लिखो. Twitter, Reddit पे तो नहीं है NEET. NTA, but yeah, write them a mail. I guess that's the best one. I don't think they have a call line, customer care line. We do. BYJU'S does have. We have an awesome customer care line. If you're looking to buy anything, description में links हैं, numbers there as well. ठीक है. Anyway, thank you everybody for your time. I'll see you परसों. Tata.